Hello guys, welcome to my YouTube channel. Myself Kirtan. Today I am going to discuss about restrictions in Java. Java programming language has various restrictions to ensure code safety and consistency. These restrictions helps maintain code quality, improve performance and prevent common programming error. The restrictions in Java helps in code safety and consistency, and it also improve the performance of the code and prevent common programming errors. Next, access modifier. There are four types of access modifier. First is public. The public access modifier allow a class, method or variable to be accessible from anywhere in the applications. The public class allows the methods and variables to access from anywhere in the applications. Next we have private. The private access modifier restricts access to the class modifier member to only within the class where it is defined. The private access modifier restricts the member to access with the class where it is defined. Protected. The protected access modifiers allow accesses to class members within the same packages and subclasses even if they are different packages. Next we have default. The default access modifier provide access to class members within the same package but not subclasses in other packages. Default class modifier provides only access to the members in the class but not the subclass members. Next we have final keywords. There are three types of final keywords: immutable variables, constant values, and enforcing inheritance rules. First, we see immutable variables. The final keywords make a variable immutable, preventing its value from being changed once it is initialized. Constant values. Constants such as mathematical or configuration values are commonly declared as final to ensure their value remains fixed throughout the program executions. Enforcing inheritance rules. The final keyword can also be applied to methods and classes to prevent them from being overridden or extended, respectively, ensuring predictable behavior. Next, we have static keywords, class level variables. The static keywords in Java is used to create variables and methods that belong to the class itself rather than to individual instance of the class. These static members can be accessed without creating an object of the class. Memory optimization. Static variables are stored in a separate memory locations. The method area, which is shared across all instances of the classes. This can help optimize memory usage, especially for data that is common across multiple objects. Next, we have utility methods. Static method. Methods are often used to provide utility functions and don't require any instance specific data. This method can be called directly on the class without the need of creating an object. Next, we have limitations. While static members can be convenient, they also have limitations. They cannot access non-static members of the classes and can lead to the tight compiling overhead. The limitations of the classes are they are non-static members of the classes and can lead to the tight compiling if overused. Developers must carefully consider the trade-off when using static keywords. Next, exceptions. Exception handling. Java's exception handling mechanisms allows developers to anticipate and manage unexpected situations, ensuring their applications remain robust and resilient. Try-catch blocks. The try-catch block is the foundation of expectations handling in Java, enabling developers to intercept the handle exceptions gracefully. Custom exceptions. Developers can create their own exceptions classes to represent unique error conditions, providing more context and control over the application's error handling capabilities. Next, inheritance. Hierarchical relationships. Inheritance allow a class to inherit properties and method from a parent of superclass, creating a hierarchical relationship between the class. The hierarchical relationship is the method from a parent or superclasses, creating a hierarchical relationship between the various classes. Next, code reuse. By inheriting from parent classes, a child class can reuse the build upon the existing functionality, reducing code duplication and promoting modularity. In this, we can reuse the parent code and use it in the child classes. Can be reused built up existing functionality, reducing code duplication and promoting modularities. Polymorphism. Inheritance enables polymorphism where a child class can override or extend the behavior of a method inherited from the parent class. Next, interfaces. There are three types of interfaces: abstract, multiple inheritance, and polymorphism. First, we're going to see abstract. Defines a contract without implementation. Multiple inheritance. Allow the classes to implement multiple interfaces. Polymorphism enables dynamic method dispatching. Interfaces in Java are powerful constructs that define a contract without an implementation details. They allow for multiple inheritance, which is not possible with regular classes. This enables polymorphism, where objects can take on different forms based on the interfaces they implement. Interfaces are essential for creating modular, extensible, and highly concept code. Conclusion. In conclusion, the various restrictions in Java, such as access modifiers, the final keyword, static methods, exception handling, inheritance rules, interfaces, nested classes, the generics, all contributes to the language's robustness and security. These features help developers write more reliable, maintainable, and scalable code. The restriction in Java helps the developers to write the code which is more reliable, maintainable, and scalable.